大家晚上好，欢迎来到原力区直播间，我是原力区 Justin，很高兴呢又和大家见面了。今天呢是我们 Web3 Infinity Hackathon 的第6期 workshop 直播。Hey guys, good evening. Welcome to the 6th session of the Web3 Infinity Hackathon workshop live stream. I'm Justin from Force Community and I'm today's host. 那首先呢，我们的无限 Web3 黑客松作为新加坡峰会最强周边赛事，目前已经汇集了上百人的报名参与。那在这里，我也再次鼓励和呼吁大家，大家如果感兴趣的话呢，就不要犹豫，向我们投递你的作品。目前我们的报名通道早就于7月1日开放了申请，那并且呢，将在北京时间的8月17日23:45前截止报名。参赛团队均可通过 DevPost 平台提交符合要求的项目。同时呢，作为此次黑客松的重磅福利之一，我们原力区也将持续在原力直播间为大家邀请到更多业内大咖来分享 IPFS Force Filecoin 以及说技术开发相关的干货以及 Web3 的最新动向。Firstly, please allow me to introduce the Web3 Infinity Hackathon to you guys. As a crucial sub-event to Phil Singapore Summit, we've already received hundreds of applications for this hackathon. And the number is still growing up, so please don't hesitate to submit your project through DevPost before 11:45, August 17th, Beijing time. The registration portal has already been open on July 1st. All of those qualified projects are welcome to join us. At the same time, for this community, we'll surely continue to invite industry experts to our live stream to share useful knowledge about developing with IPFS Filecoin and bring latest Web3 insights for everyone. 好的，那我们话不多说，接下来呢就回归主题，我来为大家隆重介绍一下今天我们 workshop 的嘉宾，是来自于 Filecoin 基金会的社区推广工程师 Robert Dowling。那他今天会为我们讲解 Web 2.0和 Web 3.0之间对于应用程序不同的需求。Filecoin 基金会呢是 Filecoin 社区的领导者，那旨在帮助人们实现他们对 Filecoin 的愿景，并支持整个分布式网络的发展。本次课程 ，Robert 将从应用架构作为切入点，分析 Web 2.0与 Web 3.0之间对于应用程序不同的需求，并进一步讨论如何构建更符合 Web 3预期的项目。So now let's get straight to the point tonight. Let me introduce you, Mr. Robert Dowling, as an associate engineer from Filecoin Foundation. We're delighted to have him tonight to talk about the differences between Web 2 and Web 3 designs of applications. Filecoin Foundation is the steward of the Filecoin community and has existed to help people build their vision of Filecoin to support the growth of the entire distributed web. In this course, Robert will use application architecture as a starting point to examine the differences in application needs between Web 2 and Web 3, as well as how to develop projects that are more in line with Web 3 standards. 那接下来我们就让 Robert 开始今天的课程。Now, let's give the floor to Robert and start off today's workshop.
Hello, Web3 Infinity Hackathon, Phil Singapore, and all our friends in Singapore. My name is Robert Dowling. I'm an associate engineer with the Filecoin Foundation. And I'm dialing in from New York, although I do wish I was in Singapore. There's nothing I love more than a nice bowl of laksa. So that being said, I'm here to talk to you today about more or less developing apps on for Web3, specifically, some projects that have been built that are really compelling and what the lessons were from those projects. But we'll start off first talking about Bitcoin and Ethereum. So, why do we care about something like a Bitcoin or a blockchain? It's because Bitcoin is a direct response to our legacy financial system, which relies on third-party intermediaries that serve as the trust mechanism between two counterparties. So when people do transactions with each other, they rely on a bank, they rely on the credit card processors, they rely on different payment websites. Bitcoin replaces those third-party intermediaries with a network of thousands of computers all over the world. They're called miners, and they enable, as the Satoshi white paper is titled, they enable, quote, peer-to-peer electronic cash, more or less peer-to-peer transactions between two counterparties, with those thousands of miners all over the world serving as that new really trustless mechanism. So, Bitcoin as a financial asset is certainly fungible. It has the features of fungible assets, store of value, medium of exchange. You send me a Bitcoin and I send you a Bitcoin. We still each have a Bitcoin. Our wallets are still worth the same. We could divide that Bitcoin up to 8 decimals. But I think what makes Bitcoin so compelling, and so, by the way, these features of money make it like cash. And again, it's a peer-to-peer electronic cash system as titled by Satoshi Nakamoto. But what makes it maybe compelling is the technology that enables you to change the amount of Bitcoin you have associated with your account. So first of all, you might want to access the Bitcoin that you have. So we have these these systems called wallets, and it's asymmetric cryptography. You have a public address, which is a unique string of letters and numbers, and you have a private key associated with that public address. And more or less, what you're able to do is you can see every public address associated with the Bitcoin blockchain. You could see all of the account balances. You can see all of the transaction history for each account, but those accounts are anonymous, so we don't really know who they are. This is in comparison to the privacy model of your legacy financial system, where the counterparties, basically the trusted third party, know both of the counterparties. We know who's doing those transactions, but the public doesn't know. So this leads to many interesting things that we're going to discuss in a moment. So this is just a visualization of what's going on here. You access the Bitcoin in your wallet with your private key. Your private key serves as your signature, more or less. And in fact, why do we call the private key a signature? Well, Satoshi Nakamoto actually defines a Bitcoin as, quote, a chain of digital signatures. So when you sign for a Bitcoin and send it from your wallet to another public address, what you're actually doing is simply, you're adding your signature to a list of digital signatures and, directing the Bitcoin along. And that chain of digital signatures is how we more or less trace who's previously owned that Bitcoin. Now we have a system that then considers each transaction and whether or not the person sending that Bitcoin has already spent that Bitcoin. What's going on there? Well, this is a problem called the double spend problem. It's typical in traditional financial systems. Effectively, a user actually ends up spending cash that they do not have in their account because they've already sent it to someone. But basically the technology just hasn't caught up and caught up to the transaction, that is, and someone was able to get a transaction in before the technology realized it. Well, the miners on Bitcoin actually check to make sure that, they check the signatures and make sure that Bitcoin hasn't been previously spent. So this solves the double spend problem. And then what the miners do is they create a block, which is just a bit of memory. They add all the transactions that haven't been double spent before to that block. And then they solve something called the nonce. That nonce is basically a cryptographic puzzle. It requires the miner spend some electricity in order to add this block and all of these transactions to the blockchain. Why do we want them to spend electricity? Well, we have a system where thousands of different people, different computers are competing to approve transactions. We have no one entity that we can go to if a transaction is wrong. So instead of giving the power to a select few of these miners to be able to, reverse transactions, we say none of them can reverse transactions. And the way we guarantee that is by making all of the transactions immutable through a financial incentive. By solving the nonce, the miner is spending electricity, and then by getting the whole block basically approved and added to the blockchain, they're actually getting newly minted Bitcoin sent to their wallet. If they try to reverse blocks, well, that's computationally expensive, and it's too expensive to even be worth trying. This is how we guarantee that transactions are immutable. Just quickly tracing a single Bitcoin transaction, you have your wallet, you sign for a transaction with your private key. This is something I want to skip, but you sign for your transaction with your public key. You have your Bitcoin associated with your public key. You want to send it to someone else's public key. You sign for the Bitcoin with your private key and send it to that third party. This transaction goes into a place called the mempool. The mempool is just where all the transactions sit until the miners pick them up and add them to a block. You'll notice that the mempool is maintained by thousands of nodes all over the world. Then the miner takes that transaction from the mempool and puts it in a block, which again is just a bit of memory. There's a process to hash the block, which basically gives it its chronological order, but that's beyond the scope of this talk. It references the previous block, which is basically the highest numbered block that it could find, and then it solves the nonce. It checks to make sure that none of those transactions have been spent in previous blocks or have been double spent by the people doing the transactions. And then it presents that block to all of the, presents the block to all of the other miners. This process is called proof of work. And if a majority of the miners agree that the nonce is valid and that none of the other transactions have been double spent in the block, well, they signal their acceptance of that block by building the next block in the chain. The miners will always build on the highest numbered or the longest chain, but the highest numbered block they could find, which is the longest, basically the chain with the most number of blocks. They will always build on the longest, most honest chain that they could find. So you can imagine actually at any given time, maybe there are some miners that are confused and are building on shorter chains. Eventually they're going to find a longer chain and start building on that. So at any given time, you could have kind of these forks in the blockchain. Now, sometimes forks are intentional, as you guys know from the Ethereum fork from Ethereum Classic or the Bitcoin Cash fork. This has to do with, at least in the case of Bitcoin Cash, some miners and developers had differences of opinion as to the future of Bitcoin and wanted to make software updates. Not all the miners agreed. So some of the miners continued to run the software associated with the old Bitcoin, and some of them decided to run the software associated with Bitcoin Cash. But you'll notice, by the way, when there is a fork, the new blockchain actually has all of the same history as the previous blockchain up until the block that they decided to fork from. Okay. So very, very compelling. Bitcoin set out to solve the double spend problem, and it actually ended up with the Byzantine fault tolerance system. The Byzantine generals problem is all about whether or not two different computers can have the same copy of a file at any given time. And in Bitcoin, we, basically have a solution to this by saying a consensus of the miners will at any time have the same version of the Bitcoin file or the most recent version of the Bitcoin blockchain. Okay. Something else I do want to say, the full history of the ledger is available to anyone who wishes to see it. That goes to the nature of those wallets. Something else I want to say is that the miner's reward actually has a half-life. So every 210,000 blocks, the miner's reward cuts in half. It started at 50, then it was 25, then it was 12 and a half. Now it sits at at 6.25. And this actually presents Bitcoin as having this kind of scarcity. There will only ever be 21 million Bitcoin because the Bitcoin money supply is kind of this inverse log function. Why was this? Well, if you look at the Genesis block of Bitcoin, the Genesis block of Bitcoin actually has a reference to the 2008 financial crisis. The creators of Bitcoin, it goes back to the cypherpunks. The cypherpunks, very libertarian. They believed in, they were kind of had their grievances with the banking system and the central banks, and this kind of governments take out debt and then print money with their central banks to pay the debt back at a cheaper value. Pay the debt back when the cash is worth, the actual unit of the cash for that country is worth less. So that maybe has something to do with the design of the money supply of Bitcoin. Okay, I want to move on here. What is Bitcoin's impact? Well, more or less we have two technological impacts. First is we solved the double spend problem, which is very important. And we have the Byzantine fault tolerance system. So these are two very interesting technological consequences. And then, of course, you have the financial consequence we just talked about. Okay, Ethereum. How does Ethereum build on Bitcoin? Well, effectively, Bitcoin's use case is payments. Now, some people see the use case also as like savings, but people have bank accounts, and bank accounts are usually used for basically savings and commerce, transactions. So Bitcoin basically had, those are more or less the two use cases for Bitcoin. But you can imagine any business logic can actually be coded as software. Any business logic, any type of contract, not just transactions. So not just like payments. You can have records, you can have voting, you could have you can have gambling or gaming. These things all require some level of business logic to implement. And Ethereum said, hey, we want to take Bitcoin and enable all of these other use cases that involve transactions of some kind. So Joe Lubin, a quote from him is, Satoshi showed us a new paradigm, which is how to interact with each other in a trustless way. Ethereum showed us scale, which is how to take that idea and apply it to many other use cases. So Ethereum is kind of like Bitcoin, and you can see my slide is almost out of date because in about 2 weeks, Bitcoin is switching from proof of work to proof of stake, which I'll explain in a minute. But Ethereum actually adds a virtual machine on top of the blockchain where you can write software, smart contracts, quote unquote, where transactions can actually be automated on some input data. So you can imagine all sorts of bureaucratic situations where this actually disintermediates the bureaucracy. For example, let's say you're a Formula One fan, and your friend is also a Formula One fan, and you both go to the Monaco Grand Prix, and you're a Ferrari fan, and your friend is a Mercedes fan, and you say, okay, let's bet on this Monaco Grand Prix. I bet 100 Ether that Ferrari will win. You bet 100, your friend bets 100 Ether that Mercedes will win. Well, you could go to the gambling house and have them escrow your Ether for you, in which case they take a fee for escrow, then they take a fee for executing the transaction. Or you could write a smart contract, send your Ether to the smart contract to be held in escrow, and then have the smart contract automatically send all of the Ether to your friend if Mercedes wins, or to you if Ferrari wins, on the input data of the outcome of the Monaco Grand Prix. So these are the types of examples where you can imagine you can actually disintermediate these third parties that we've relied on for a while. Now, this is a comparison of Bitcoin and Ethereum. Ethereum operates much, basically the average block creation time of Bitcoin is about every 10 minutes. The average block creation time of Ethereum is every 10 to 20 seconds. The Bitcoin mining reward has a half-life. Ethereum doesn't. It's 2 Ether fixed for every block. And more or less the reason for this is, and by the way, Bitcoin has no transaction fees, although you can opt to pay a transaction fee if you want miners to include your transaction more quickly. Ethereum has a gas fee. And the reason for this is, Bitcoin's kind of analog asset is more like a cash or a gold. And Ethereum was meant to be oil, where the Ether is actually serving, Bitcoin's kind of this commodity asset, but Ether is kind of serving as the fuel for all of these smart contracts that have been written, all of this business logic. So more or less, Ether's supposed to be like digital oil, and you pay a gas fee to have the smart contracts executed. Another interesting difference between Bitcoin and Ethereum is that Ethereum is a state machine, which means that Ethereum actually has one big data structure that keeps track of the current balances of every account at any given time. So when you're actually sending an Ethereum transaction, you're actually, it kind of works more like Venmo or a Cash App or, your bank account, where if you want to send money to a third party, you send the exact amount and that gets sent to the third party. And then your wallets are updated in this state machine, your wallet account balances. Bitcoin doesn't work that way. Bitcoin works on this idea of an unspent transaction output. So what does this mean? Well, Bitcoin acts much more like cash. So let's say you're hungry for a nice plate of maybe some roast duck and some maybe suyok pork belly and some noodles, and you go down to the hawker stalls and you find a hawker stall you really like, and you say to the hawker stall shop owner, "Hey, I'd like a plate of your best noodles and pork belly and duck. I have 10 Singapore dollars. I know," and basically, let's say this plate costs 5 Singapore dollars. So you'll give the shop owner your 10 Singapore dollar note, and what is actually happening, the the hawker stall shop owner is actually going to take your $10, divide it into 2 accounts of $5, keep one of those $5 because that $5 accounts, because that's the cost of the plate that you're buying for lunch, and give you back the other $5 account, more or less. So this is actually how Bitcoin works is, in most cases, you're actually, when you do a transaction, you're actually sending, practically speaking, more Bitcoin to that third party than you actually mean to send. But what ends up happening is that excess Bitcoin gets, divided into the money you want to send to the person you're sending the Bitcoin to, and another account that you get back as the change account. Another interesting thing about Ethereum is that, we just discussed Bitcoin and how it's a proof of work mechanism. They solved the nonce, and this is evidence that they've, spent some electricity, and the miners then receive miners' rewards in the form of newly minted Bitcoin for solving that nonce. Hackers, if they wanted to reverse transactions, would have to perform a 51% attack, which means they have more electrical power than 51%. They have 51% of all of the computing power on that blockchain network. Now, this is maybe very unlikely for Bitcoin, but it has happened to other blockchains that have smaller numbers of miners. But it is, again, highly unlikely for Bitcoin. Ethereum, in about 2 weeks, is switching to something called proof of stake. They're calling this the merge. And more or less, what happens is you can validate transactions, serve as a validator, depending on whether or not you have provided Ether of your own to put up as collateral So more or less, validators give 32 Ether at least to put up as collateral. They then have the power to add transactions to blocks and serve as basically collect transaction fees from these Ether transactions. And if they act in a dishonest way, their Ether that they put up to stake will get burned, as an example. So, people debate whether or not this is a good idea or not. Either way, it's happening. So whether or not you're a fan of proof of work or proof of stake, it's happening. What's interesting is that, to perform a 51% attack on a proof of stake mechanism, you'd have to have 51% of all of the crypto, in this case, Ether, in circulation. Okay. Smart contracts. Okay. This is, by the way, Ethereum. Again, Ether is the oil. All these smart contracts are supposed to serve as an app store of blockchain. So you have all sorts of interesting apps that are being built on Ethereum. I actually want to skip ahead here. So use cases. Anything is possible. Anything that involves record keeping or transactions, you can use a blockchain for. Interesting project called Polymath. In Polymath, your tokens that are built on Polymath actually represent securities. They represent stock in a company. So there's a lot of interesting things you could do. These are some more use cases. The governments are adopting it. Dubai, infamously, dating back to 2020, wanted to implement a blockchain at every one of their government agencies. Maybe the most interesting, and one that countries like Georgia and Nigeria are looking into, are to use blockchain to guarantee who owns land titles, like, who owns the title to what land. This is a very interesting use case. And probably the most compelling use case is that of identity. So what makes blockchain interesting is that at any given time, you know who all of the trusted actors are. And you could imagine situations, let's say with a college. You go to college, you spend 4 years and a lot of money to earn your degree. And the college owns your transcript and your graduation information. Well, let's say that college shuts down for one reason or another. If both you and the college were on the blockchain at the same time, we could actually more or less discriminate between your wallet and the university's wallet. The university's wallet being the vendor of data and your wallet being the owner of that data. And we can have, at that time, the college attest to your wallet, your transcripts and your graduation information, even if that college goes out of business in the future. So that transcript and that graduation information can actually outlive the vendor of the data, thanks to the trust that the blockchain provides. Okay, now to get into maybe the title of the talk. What's the difference? You're building on Web 2, you're building on Web 3. What's the difference? And I just wanted to highlight some differences that make it very interesting. So first of all, in general, blockchains are open source. And this is really great because anyone can contribute to the Bitcoin or the Ethereum code, but they can also, in the case of Ethereum, actually propose standards for different types of smart contracts. So you have the ERC20 initial coin offering smart contract. This allows you to mint other fungible crypto tokens on Ethereum other than just Ether. And usually the way it works is a wallet sends Ether to the smart contract address of the ERC20 token. And then that ERC20 token address sends back to that wallet the newly minted token, whatever the exchange rate is, and sends the Ether along to the wallet that created the smart contract to begin with. So, not to get too into the weeds, but these are, more or less the functions and events that you would need if you wanted to make an ERC20 token contract. Things like the name, the symbol, the transfer function, yeah, all this stuff, all well and good. ERC 721, very similar, except in this case, this is for non-fungible tokens. So you can't divide these tokens and each one is unique. I'm sure many of you know all about NFTs at this point. What's interesting to note is that, you know, the actual art file associated with these NFT tokens are usually not on Ethereum. They're usually stored on some other platform. And in fact, you know, the art file is linked from the ERC 721 token to some other platform where the art file exists. So more or less, these ERC 721s are more serving as like certificates of ownership. And the art, you know, maybe it exists, you know, 60 million at least of these NFTs actually are stored on another platform called Filecoin IPFS, which we'll talk about in a moment. Interestingly enough, with these NFTs, you know, just like any other crypto asset, we know the whole history of the NFTs. So we know who's owned it previously, which is actually a major problem in art, especially historic pieces and antiquities, because, you know, if there's a break in the receipt of ownership or the provenance, you know, it's totally possible that you have in your possession some forgery. So guaranteeing ownership and valid, you know, basically the history of ownership is very important. It's a very important use case. These initial coin offerings, this is a great visualization from a great company called Elementus, led by Max Galka, who's the founder and CEO. These ICOs, again, just like a crypto asset, we know the total supply, we know the ether that comes into the smart contract, we know the, you know, which wallets own which amount of the tokens, and these things can be visualized. And so this is a visualization over time of the, you know, the ICO token raises that were done between, you know, 2015 and 2019, basically. So why is this data so important that we're actually following and tracing the data? Well, this is something that you should consider with your Web3 development. Why is that? Well, in the early days of these smart contracts, and actually, please excuse the title here. This is actually from one of my slides when I talk about law and the blockchain. But you know, talking about the actual situation, one of the earliest projects, it was called the DAO. This is one of the earliest projects on Ethereum. And what we have is more or less an autonomous company that is operated by smart contracts. So how did the DAO work? Basically, you sent ether to the DAO smart contracts, and then the proportion of ether that you sent that was received by the DAO is your voting power. And you vote with the rest of the crowd that sent ether to the DAO on where you should invest the money that's been put into the DAO. Now, someone exploited the smart contracts, and you would invest in like other crypto projects on the blockchain. Okay. So someone exploited these smart contracts, and there's two reasons for this. First of all, the exploit actually resulted in the theft of, you know, many millions of dollars. You know, $150 million of ether at the time was stolen. And what's very interesting about this is, first of all, if we had some type of code auditing, you know, which today we call, code auditing, smart contract auditing, maybe that exploit would have been debugged and found. And then the other issue is, if at the time we were indexing and tracing the data associated with these smart contracts, we would have been able to catch that exploit on the first block, but we didn't have those technologies at that time back in 2016. It wasn't until, you know, people started building things to help us look at this. So what ended up happening actually is Vitalik and the Ethereum Foundation hard forked Ethereum from the original Ethereum. The original Ethereum today is called Ethereum Classic. There was a hard fork at the block just before the DAO was launched. And the Ethereum that people know and build on today, and which is switching to proof of stake, is this hard forked Ethereum. Okay, yes, hard fork. And the old Ethereum, which still has the theft on it, is called Ethereum Classic, which many of you probably know about. So tracing, doing some data analysis on your smart contract, if it's a DeFi project, for example, is very important because you can see what's going on. And if there's a problem, you could catch it very quickly. So that's one of the major things you should do in developing a Web3 or DeFi application that maybe you wouldn't, maybe you would have done in Web2. You would have probably traced the transactions, but the invariance of the blockchain, more or less the data structure, the transactions and what's available to you and how it's public, makes this uniquely possible and very interesting. The other thing this allows us to do is actually trace through, if you have a smart contract like an ICO, you can actually see who's put what money into what ICO contract. So here we have a project called Car Taxi. They claim to have raised $7 million to an ICO. And the truth of the matter is they actually raised $1 million in the first round. We know the smart contract sends money to the wallets associated with the people that set up the smart contract. All these little blue dots are the third-party addresses that are investing in this ICO. So you can see the blue dots send the money into this red smart contract. This sends the money to the Car Taxi wallet. And then we have a second round where, yeah, we still have some third parties, but there's definitely some money going in and out between the Car Taxi wallets and the second round of the smart contract. Now, even though all of the wallets are just letters and numbers, a string of letters and numbers and totally anonymous, we know from the advertising and the marketing of this smart contract that this smart contract is associated with the Car Taxi company. Therefore, we can actually identify this wallet as belonging to Car Taxi. And what we actually have is, Car Taxi was sending money to the smart contract that they already had to make it look like more investors were interested in the ICO than actually were. And you can imagine this is like some level of deception. And what they actually got in that second round from third-party investors was only $1 million. So they claimed to have raised $7 million. Actually, they only raised $2 million, and $5 million of that was just circled through their own wallets. Okay. Another thing to talk about. So that's a way that the open, transparent nature of the blockchain and having all that transaction data is very important. Well, let's talk a little bit about privacy and how, if you're building other types of apps, you might want some different type of privacy regime other than totally open and transparent. And Zcash is a very interesting project that tries to provide privacy to transactions using something called a zero knowledge proof, ZK snarks. This is beyond the scope of this talk, but I would encourage you all to look into it. It's a very, very compelling work is being done at the Zcash project. So, but what I want to talk to you about is an Ethereum anonymous voting machine. So you could imagine that one of the reasons why we might want to use a blockchain is for records. And part of it is we can guarantee conditions on those records. For example, provable ownership of the records, or in the case of voting, we can guarantee some legitimacy with respect to voting because, we could expect some level of legitimacy with respect to voting because of the nature of the blockchain, because we have these thousands of miners all over the world competing to approve the transactions. And, just like you wouldn't be able to double spend an ether you wouldn't be able to vote twice in an election, thanks to this kind of nature of the blockchain. But you would imagine that you want to keep votes private, because if one of the winners wins, you wouldn't want the winning or the incumbent winner of the election to then discriminate against all the people that voted against them. So we want to basically use the blockchain to guarantee that only the right people who should be voting are voting. So we want to use the blockchain to make sure only the right people that we want to vote are voting. So only the people eligible to vote are voting. And we want to use the blockchain to make sure no one votes twice. But we want to make sure those votes are private, certainly private and anonymous. And Elijah Jasso, who just graduated the University of Pennsylvania, is now working as a software engineer for Coinbase, built this really, really great voting machine that has some level of privacy for the electors. Now, unfortunately, we don't have time for a demo, but I do just want to make a note that the voting machine actually is voting smart contracts. So there ends up being two smart contracts associated with this design. One is the election creator. So one wallet runs a smart contract that creates an election and basically specifies which other wallets are allowed to vote in that election and who the candidates are. And then you have another smart contract that actually collects the votes and allows the other participants to actually compute the outcome of the election for themselves. So there's some encryption going on here to allow for that level of anonymity and privacy associated with these votes, basically, and the votes are a transaction. So just walking through how the app actually works, you have the creation of the election by the election creator smart contract. The election official, which is just one of the Ethereum wallets, has an array of the candidates and basically who you can vote for, and then array of addresses that are allowed to vote for this in this election. And then there are these cryptography constants, a prime and a generator. And without getting into how that cryptography works, just for the sake of the talk, just accept that this cryptography works to allow us to do what we want it to do, which is to more or less encrypt the votes and keep them anonymous from all of the other participants in the election, and certainly the public. This is basically how this app works. Voters communicate with the election smart contract to retrieve a prime and a generator, the voters and the candidates. The voters pick their secret key and generate their public key, and voters send their generated public key to the smart contract. Yep. Okay. The voters receive all of the public keys from the election smart contract, and they're actually able to calculate their own encrypted vote and send their encrypted vote to the election smart contract. This is, again, more on the encryption, which is beyond the scope of the talk, but at the end of the day, voters end up receiving all of the votes from the election smart contract, and they could independently calculate the winner thanks to this, basically they're able to independently calculate the winner, but this encryption that has been added allows those votes to effectively, we don't know who voted for who necessarily. So this is something you might want to consider if your Web3 app is actually dealing with sensitive information like election data. You might want to consider using some encryption to make sure that that data has some level of anonymity and privacy beyond the anonymity that the Ethereum blockchain already provides. And actually, we're very grateful to Elijah. The Filecoin Foundation and a platform called CoRise just partnered, and the course is running now, to teach a course on Web3 software development. And this voting machine is actually one of the assignments. So please actually reach out if you want to do this assignment. It's something that can be arranged. Okay, the last thing I want to say, and we're out of time. I think I'm coming up on an hour, but so first we have, we're building Web3 apps. Something that makes it very interesting is the open nature of the data. And then you might have situations where you want to keep that data private. I just wanted to talk briefly about Filecoin IPFS. So, I won't walk through the code. If you want to see it, you're welcome to reach out to me, but we'll just talk about the consequence of a very interesting decentralized rideshare app that has been built by Sydney Lai, who used to work for Protocol Labs. And we're very grateful to her also for providing us with that software. So first of all, decentralized storage platform, what is it? Well, Filecoin IPFS. IPFS stands for Interplanetary File System. This is a peer-to-peer network for storing and sharing data in a distributed file system. More or less, it's a hypermedia protocol that allows you to share files. And then Filecoin is a blockchain that serves as a cryptocurrency. And that cryptocurrency is actually used to more or less allow users to rent memory on other people's laptops or devices or any computer. So users are actually renting memory on other people's computer using Filecoin to pay the rent, and they're storing files on other people's computers. So this is, instead of having miners that are, approving these transactions, we have storage providers that are actually, providing memory to allow you to, store large data sets, store NFTs. Again, 60 million NFTs are stored on Filecoin IPFS. Huge data sets have been stored by Harvard libraries, the Internet Archive, New York City. Some really compelling stuff is being done on Filecoin IPFS. Something else I'll note is that there's two very interesting proof of stakes that actually use $0 proofs, but again, beyond the scope of this talk, but if you wanted to look into it, I'd highly recommend. We have proof of space-time and proof of replication. So these are types of proof of stakes that enable us to ensure that the files that are being stored on Filecoin IPFS, basically these proof of stakes guarantee that the storage providers actually holding the file we expect them to hold and that we're paying them rent to hold. The last thing I'll say about Filecoin IPFS that makes it compelling is, on the internet, we have the internet protocol, which basically indexes every website, every device, every file with their location. So you can have multiple copies of the same file at different locations. You can have a file name something at a certain location, which is fine, but you could have it named something that it's not. So for example, you could have www.puppies.com/beagle, and you have a beagle at that address. Or you can have www.dogs.com/beagle, and you can have the same photo of that beagle at that second address. So there's some redundancy there. We have two copies of the same beagle photo. Or you can have www.puppies.com/chihuahua, but that's not actually a photo of a chihuahua. That's actually a photo of your beagle still. And by the way, if someone decides to manipulate that photo of a beagle and maybe add a friendly, maybe they add a kitten to that photo of the beagle, or they add a party hat to the beagle, you could still have that manipulated file at www.puppies.com/beagle. So more or less what you have with Internet Protocol is redundancy multiple copies of files everywhere, and you have addressing that tells us nothing about the file itself, more or less, the name of the files and the names of the websites could have nothing to do with the content. And so this brings us to an interesting new regime that Filecoin IPFS uses, which is called content addressing. And this actually uses the file as an input to calculating its address. More or less, if someone tampers with the file, that address actually changes. And you never have two copies of the file anywhere. You have only the one content address, so there's no redundancy. So if you have the content address, you can immediately find the file. So there's a great resource called Proto School. The website is www.proto.school. If you're interested in a open and free to use resource to actually learn more about Filecoin and IPFS and content addressing. But something I did want to say is, Sydney built this decentralized rideshare. And again, we're out of time to go through the software. But if you're interested in what's going on here, please reach out to me. I'll leave my email at the end. But something that was interesting is due to the decentralized nature of the Filecoin IPFS platform, Sydney instead, in building her rideshare app, if she was doing this on AWS or a Web2 platform, she would have one database with maybe 20 million drivers and passengers, and she would do the matching with a huge, a huge program with many, many lines, thousands of lines of code. But on Filecoin IPFS, in her minimal viable product, what she found was it didn't take a lot of code. The actual coding was, just few lines. But each user, each passenger, and each driver actually required their own JSON file. So instead of one file with 20 million passengers and drivers on it, she had 20 million files on Filecoin IPFS. So and she was able to use this subscription to IPFS topic that allowed her to match the zip codes associated with each the drivers and the riders. So this is a project. If you're interested in, please reach out to me. But that just more or less highlights the difference between developing for Web 2 or Web 3. So, okay, thank you so much. This is my university email. You can reach me there, or you can reach me at robert@fil.org. That's robert@fil.org. I'm happy to answer any questions. I want to thank the organizers of the Web3 Infinity Hackathon and Phil Singapore for having me all the way from New York. Again, I'm sorry. There's nothing I would have liked more than to join you guys in Singapore. But hopefully I'll be able to join for future editions of the hackathon and conference. Okay, thank you so much. Cheers.
好的，那我们也非常感谢 Robert 给我们带来非常精彩的课程啊。那相信大家听完以后呢，可能对 Web 2.0和 Web 3.0之间应用的不同需求，那有了自己的一定的认识，也从这课程中学习到了很多不一样的视角。那对于我们想要重新去学习一遍，或者说错过了本次直播的朋友们呢，也不用担心，我们所有的中英双语对应的教程直播课都会在直播结束之后上传到原力区的 B 站和 Forest Web3 Community 的 YouTube 频道，那来供大家学习和参考。All right, thanks so much for Robert to giving us this amazing sharing. I believe all of our audience must have a deeper understanding toward the differences between Web 2 and Web 3 designs of applications. For those who want to watch it again or fail to attend in time, don't worry. All of our live stream videos will be uploaded to our Bilibili and YouTube channel, respectively in Chinese and English. Just make sure you check them out. 那么到这边呢，我们今天的直播分享也就接近尾声了。那我这边也再次鼓励大家来报名参加我们的无限 Web 3黑客松，分享丰厚的10万美金的奖金。同时呢，也希望朋友们可以持续关注我们的原力区。 我们的下一次直播依旧是下周二同一时间。那我们也准备了 VC Talks 以及 Winners Call 2期新的节目。那希望我们下周不见不散。It's all for today. I'd like to once again encourage you to sign up for our Web3 Infinity Hackathon and share the huge prize of over $100,000. Meanwhile, don't forget to tune in to our live stream channel. There will be 2 new featured sessions coming up, VC Talks and Winners Call. Our next live broadcast will be at the same time next week. So see you guys next week.